All right, this is the first lesson of Chapter 8 for Algebra, and we're dealing with complex numbers in Chapter 8. And so 8.1 is imaginary numbers. 8.1, imaginary numbers. And like always, the first lesson of any chapter is really going to set the tone and really going to be key and crucial in understanding the rest of the chapter. All right, so here we go. Pure imaginary numbers, 8.1. All right, an imaginary number is any even root. All right, before I go any further, remember the index determines what type of root it is. So if you had just a normal square root symbol, the index is not shown and it's a 2. Fourth root would be an even root, sixth root would be an even root, eighth root would be an even root, etc., 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 etc. So an imaginary number is any even root of a negative radicand. Any even root of a negative radicand. All right, so for example, you can see here we've got a square root, right? There's no index indicated. So I have a square root. I'm going to take my red here and put a red negative, and I'm going to take my black here and stick in a black 5. So we've got the square root of negative 5. So we have an even root of a negative radicand. And remember, what does square root tell you? It really, the operation is what number times itself 2 times equals, in this case, negative 5. What number times itself 2 times equals negative 5? Well, here's the problem. There is no such number. There's no real number. Does not exist. No such real number exists. I'm going to move this down so I can write here underneath where we're at right now. But there's no number that exists. You don't need to write this, but just some thinking, right? You could say, okay, well, 5 times negative 5, well, that in and of itself doesn't give us a negative 5 anyhow. What number times itself? And I probably should have done myself a little bit a favor here by giving you an example that works. Here, let me show you. Don't need to write this. Square root of negative 25. Okay, so there now we're thinking, okay, hey, 5 and 5. So you might say, well, 5 times a negative 5. Well, it doesn't work because that's not the number times itself. This is a 5 and this is a negative 5. That's not itself. You can't do that. What about negative 5 times negative 5? Well, that gives you a positive 25. That's not the radicand. So a negative 5 times a negative 5 doesn't give you a negative 25. And you can't use a positive and a negative. So the reality is no such real number exists. That's exactly the point. No such real number exists. It's not there. It does not exist. And so because of that, we end up with imaginary numbers. Okay, so let's write this underneath. Implies no real number exists. No real number exists. That's the situation when you have an even root of a negative radicand. An even root of a negative radicand. Okay, so by definition, the square root of negative 1 is I, an imaginary number. Always write it as a script I because you don't want to get it confused with ones. And so always put the little tail, add the dot, and that will clearly mark it as an I. So what's the value of I? The square root of negative 1. What's the value of the square root of negative 1? It is I. All right, so if you look below here, and here we have the situation. So if you're looking here, I'm looking right here. We've got the square root of negative 5, right? Square root of negative 5. And so then I said that would be the same as the square root of a negative 1 times 5, right? And that's true. And then I could split it up. We have this concept when we're simplifying radicals. We don't always show the step, but it's true where we could split it up, right? That's exactly what we did. I split up the square root of negative 1 times the square root of 5. Again, if you were to multiply them out, you'd be right back to where you were. Okay, so what is the square root of negative 1? It is I. And what is the square root of 5? It is the square root of 5. And you end up with I times the square root of 5, which equals the square root of 5i. Now, I will tell you this. This is proper form with the coefficient in the front, the real part, and the imaginary part in the back. This is proper form here. This part is real. It's a real number. It's irrational, but it's real. Okay? And the I is the imaginary part. However, a lot do not like to have the I in the back because sometimes it could be confused with this. Don't write this, but what if it were this situation? Is that I under the radical sign and part of the radicand, or is it outside? And we don't know, and it's not clear. So for clarity's sake, a lot of times we will put the I in front, though that's technically not proper form. It is way clearer, and many would prefer to put the I in front. Okay, commutative property, right? You can get away with that, no problem. You can change the order, right? As long as things are being multiplied. Okay, so now let's learn this key pattern. Key pattern for the values of I. And this is very important. This is going to come into play in most of what we're going to do this chapter. So it's important that we learn the pattern now. And so hopefully I can teach that to you. All right, so I've got a pattern here. And we start off with I to the first power. Right, I'm right here. Right, I to the first power. All right, so I to the first power is the square root of -1. And what's the square root of -1? It is I. And that's all that one was. That was pretty boring. I to the first is I. And so you start off with I. Well, second, look at what we've got here. We've got the square root of -1 times the square root of -1. If you wanted to, you could write that together like this. What's the square root of -1 times -1? And I hope you say -1. So I to the first is I squared is -1. Why is that boxed in red? This is really, really, really important. Anytime you end up with an I squared, you must know to convert it to a -1. And this will come up regularly throughout Chapter 8 and your use of imaginary numbers. So I squared is a -1. Very, very important. Okay, we go next to an I cubed. And I could write an I cubed, you see it right here, as an I squared times an I, right? Well, what did we just learn the I squared was? The I squared was a -1 times the I. What's -1 times I? -I. And now we have -I. So far we've got I to the first is I squared is -1, I cubed is -I. Now let's do I to the fourth. I to the fourth, and if we wanted to, we could break it up to I squared times I squared. Right? I squared times I squared. What's an I squared? A -1 times what's an I squared? A -1. What's a -1 times a -1? It is a 1. And there's our pattern. I, -1, -I1. I, -1, -I1. I, -1, -I1. You got to learn that pattern. You have to know that pattern. That pattern is key to everything we're going to do this chapter. I, -1, -I1. That is the pattern. It's something you should memorize, something you should have in your brain. It's something you shouldn't get mixed up with. You should know it well, know it cold. All right? Let's continue with the pattern. What about I to the fifth? Well, an I to the fifth is an I to the fourth times I. What was an I to the fourth? It was a 1, wasn't it? And I to the fourth was a 1. So this, in fact, is 1. What's 1 times I? I. Aha. I to the sixth. What's an I to the fourth? 1. What's an I squared? Look back at your chart right up above. What's an I squared? A -1. So what's 1 times -1? -1. You getting the idea? I to the seventh. And I to the fourth is 1. So it's 1 times I cubed. What was an I cubed? An I cubed was a -I. And what's an I to the eighth? A 1 times a 1, which is a 1. I, -1, -I1. I, negative 1, negative I, 1. So if I asked you what's I to the ninth, what would you say? What would you say? I to the ninth. I hope you would say I. I to the 10th, negative 1. I to the 11th, negative I. And I to the 12th, 1. That pattern just repeats forever and ever. So this is I, negative 1, negative I, 1. I to the 13th, I. I to the 14th, negative 1. I to the 15th, negative I. I to the 16th, 1. I to the 17th, etc., etc., etc. Learn the pattern. It is key. I, negative 1, negative I, 1. Very, very, very important. Okay, so at times you can be asked to simplify imaginary numbers. So here we have I to the 18th. So how do you do that? Well, the key is to remove as many I to the 4th powers as possible. And the reason you're doing this is I to the 4th power is 1, right? Let's go back just a moment to the previous page and notice all these I to the 4ths are just 1s. If we would have done I to the 9th, it would have been I to the 4th times I to the 4th times I. So that's the reality. Those are all 1s. So we want to remove as many as possible. So if you look at the example here below, I to the 18th. Excuse me. Stay with me here. I to the 4th times I to the 4th is I to the 8th times I to the 4th is I to the 12th times I to the 4th is I to the 16th times I squared is I to the 18th. Okay, so we've got I to the 18th. So remember, what is an I to the 4th? It's a 1. What's an I to the 4th? It's a 1. What's an I to the 4th? It's a 1. What's an I to the 4th? It's a 1 times an I squared. Go back to your chart. What's the pattern? What's the value of an I squared? I, negative 1, negative I, 1. So we really end up with I squared, which is I, negative 1. Negative I, 1. What's our value? Negative 1. Okay? That's the idea. Now, there is a simpler way. There is definitely a simpler way than having to do all these I to the 4th. Because what if I give you, and I will on the quiz or test, I to the 379th? Okay, you don't want to sit there forever with 4s. That would be cumbersome, to say the least. So here's the easier way. All right, this can be done easily by dividing the exponent by 4 and reading the remainder. Because you're dividing by 4, everything is in fourths. So look over at the chart here at the left. If these are your remainders, right? These are the remainders. You divide and you get a remainder of 0.25. Hey, that meant you had 1/4 left. One of the 4 i's, that's an I. And what is the value of I? I. If you had 0.5 left, you have 2 i's, or I squared. I, negative 1. If you have 0.75 remainder, you had 3 i's left. I, negative 1, negative I. And if you had no remainder, there were 4 of the 4 i's. And I to the 4th is 1. I, negative 1, negative I, 1. You can just simply read the remainders. Okay, so let's do the problems here at the right. I to the 39th. You just grab your calculator. Now, if you want to do these on your own, pause the video and go ahead and see what you can do, and then you can turn it back on and see if you were thinking correctly. All right, so I to the 39th, I'm going to take 39. I'm dividing by 4. I'm reading my remainder. Oh, it's 0.75. 0.75 is an I cubed, and an I cubed is negative I, right? And I really didn't even need to write the I cubed. It's just negative I is the answer. All right, 122. I to the 122nd. 122 divided by 4. Boy, this is hard. 30.5. 30.5. 0.5 is an I squared. That's a negative 1. Whoa, that was ugly. A negative 1. 741. Punch it in my calculator. Divide it by 4. Read the remainder. 0.25. Oh, that's an I. That's as easy as those are. If. They're easy if you know this. If you know that They are very, 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 very easy if, excuse me, if you know that. All right, what's next? A. A pure, and that's the title of 8.1. A pure imaginary number is one where there is only the imaginary parts. Only the imaginary parts. Example, something like 3i. Something like negative 5i. Okay. They say there's more than the real part. No, it's just, remember, the coefficient tells you how many. A 3i is 3 times the I. A negative 5i is negative 5 times the I. Square root of 3i. Again, that's the more confusing form. I like it better when the I is in front. I times the square root of 7. It could have fraction. How about 5/7? Usually the I goes across from the fraction bar like that. That's proper form. 5/7 I. You can even have a radical in the numerator. How about negative the square root of 3 over 2i? This is a pure imaginary number. Now, we'll get into this next lesson, but just to help you understand, okay, so what if it's not a pure imaginary number? What would it look like? Something like this. So this, don't write this, but this is what a something that is not a pure imaginary number, this is what it would look like. Something like 5 minus 2i. This is all one thing. It's one thing. It's called a complex number. It has a real part, the 5, and the imaginary part, the negative 2i. So it has a real component and an imaginary component. And we'll talk all about those things. We'll even apply them to vectors down the road and get into some pretty interesting stuff. But that's a complex number. That is not a pure imaginary number because it has a real part and an imaginary part. What we're dealing with today are pure imaginary numbers. All they have is the imaginary part. Okay, let's do some simplification. These are pretty easy. We've got the square root of negative 9. And if you want, you can break it up and think of it this way. The square root of negative 1 times the square root of 9. What's the square root of negative 1? It is I. What's the square root of 9? It is 3. Now, I will tell you this. You have to be careful. Imaginary numbers always come with a conjugate. So this is really plus or minus 3i. All right, the 3 for the square root of 9, the I for the square root of negative 1, and include the conjugate. So let's put a little asterisk here. Imaginary numbers come with its conjugate. Now, we've talked about conjugates before. Now, remember, this is the back end of the binomial. The real number part is 0. 0 plus 3i, 0 minus 3i are the two conjugates. Okay, we'll talk more about that later on. All right, so look at something like this. The square root of 28. All right, I can think of it this way. Square root of 4 times the square root of negative 1 times the square root of 7. And I hope you agree. 4 times negative 1 is negative, don't write this in your notes, negative 4, and negative 4 times 7 is that negative 28, right? So no problem there. We've simply broken up the negative 28 into manageable parts. Square root of 4 we know is 2. Square root of negative 1 is I. Square root of 7 is square root of 7. And because it's an imaginary number, I remember that we have conjugates. Plus or minus 2i times the square root of 7. Plus or minus 2i times the square root of 7. All right, let's get to our last things here. All right, so example A here, x squared plus 16 equals 0. Pretty simplistic problem. Let's move that 16 to the other side. Now, in the past, we would get to this point and say, hey, I want to take the square root of both sides, and we'd say no solution. Technically, it was no real number solution. But we can do this now. Square root of x squared is x, plus or minus square root of 16 is 4, and the square root of negative 1 is I, plus or minus 4I, plus or minus 4I. So look, here's what most people think. As soon as they see a negative radicand with an even root, square root, that's the I part. Then they deal with the 16, square root of 16 is 4. Okay, plus or minus 4I. That's the thought process, okay? Look at B here. Again, if you want to do this on your own, go ahead and pause the video, and you can do this on your own. Let's go ahead and move the 48. So you get 9y squared equals negative 44. Let's go ahead and move the 9. You get y squared equals negative 44 divided by 9. You have now isolated the squared term, and you're ready now to take square root of both sides, right? All right, again, I can't emphasize enough. Don't forget the plus minus. 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 Square root of y squared is y. All right, be careful now. Let's do I'm going to use some color here. Okay, there's the negative, right? Okay, let me just pause here before I skip too many steps and you guys get confused. Remember, we learned that you can split up a radical, right? Into the root of the numerator over the root of the denominator. Okay. So there's the I, all right? So I'm going to stick the I out in front of this fraction bar. The numerator of 44 is a 4 times 11. What's the square root of 4? 2. What do I still have? Square root of 11. That's the top. The bottom is easy. Square root of 9 is 3. And what do I end up with? Plus or minus 2 times the square root of 11 over 3i. That's the way these go. All right. Some work tonight to hopefully, or tomorrow night, hopefully to allow you to understand and assimilate this. So let me go back and recap here real quickly. What are imaginary numbers? It's when you have an even root of a negative radicand. An even root of a negative radicand. So the square root of negative 1 is I, imaginary number. Square root of negative 1 is I. Don't forget the pattern. I to the first is I squared negative 1, I cubed negative I to the fourth 1, and that pattern continues to repeat itself and repeat itself. I, negative 1, negative I, 1. I, negative 1, negative I, 1. How do you figure out the value of something like I to the 18th? You simply divide the 18 by 4 and read the remainder. If you remember that 0.25 is I, 0.5 is I squared, negative 1. 0.75 is I cubed, or negative I, and 0.0 remainder is I to the fourth, or 1. Then you'll remember the chart. All right, pure imaginary numbers has just the imaginary part. All right, bunch of examples there and a couple examples of simplifying, and then some equations where we can solve with imaginary numbers. All right, that's the lesson. I hope it's understandable. Remember, it's here now, and you can come back anytime and review it. Those of you that are struggling, I would advise you a couple days in, after we get a few more things, come back and review the lesson, and it'll help you to lay a good foundation. All right, have a good night.